possibility to check simulation mode like packet tracer?
You can capture the link in GNS3 through IRSAR.
Only capture the link.
Yes. There we can see the messages.
And sir, even जी का if you can share us a link sir download करने के लिए something install करने
YouTube
के
पे
लिए
अवेलेबल है मेरे चैनल पे.
शेयर पॉइंट में कहीं है आपकी इमेजेस वगैरह?
इमेजेस भी उसके डिस्क्रिप्शन में शायद है. इवन जी सेटअप
जी
PM networking. So here is the video. This video
I am
will
getting
guide you, and even link is also there in the description. Here is my drive link. Okay, Rahul.
कहाँ पे डाला आपने?
सर चैट में वो व्हाट्सएप में भेज दीजिए.
हाँ व्हाट्सएप पे भेज दीजिए. यहाँ चैट में तो
यहाँ पे चैट में दे दूँ.
सर
So
व्हाट्सएप
WhatsApp
पे भेज दीजिए.
व्हाट्सएप पे भी
ये
भेज
चैट
दूँगा.
ये चैट गायब हो जाती है ना.
भेज दूंगा व्हाट्सएप पे. याद रहेगा मुझे.
ये मैं ही भेज देता हूँ सर ये लिंक कॉपी पेस्ट करके.
ऐसे YouTube पे बस सर्च करना है इवन जी सेटअप PM नेटवर्किंग. You can find like videos on all topics of routing and switching on my channel. Just type the topic name and then PM networking. Right, you will find
Correct.
the video.
Correct.
Okay, so can I start?
Yes.
Yes, sir.
Okay, so you all know OSPF is a link state routing protocol, and you know some properties of link state. So guys, tell me some properties of link state routing protocol, the behavior.
But
Sir,
link
links
state protocol.
this stops here, sir. Sir,
Sir, it has the network visibility of entire topology of network basically. Link state protocol says that.
Very good. This is really very important point, which is a router, OSPF router will have complete view of topology, right? A link state routing protocol will have complete view of topology, right? Then
emails भेजने थे सारे.
anything else? Yes, Rakesh, are you speaking?
No, sorry.
Okay.
Sorry,
Hello. Yeah. Hi. Yes.
So link state routing protocol maintain how many types of table?
So 3 tables, network table,
Three
topology
table.
table, and routing.
Three tables.
Neighbor table, database,
database.
and routing table.
So database is topology table only, right?
Yeah, in EIGRP it's topology table. In OSPF we are saying database.
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 And this is very interesting, like how routers are going to build the database
Yes, sir.
in OSPF. Let me tell you first some basic points about OSPF routing protocol. After that, we'll see the working.
Sir, a gentle reminder about the recording, please.
Yeah, I have started the recording. Already started.
तो कल वाली भी ड्राइव में डालेंगे ना?
हाँ डालूंगा ना, बिल्कुल. OSPF. OSPF stands for Open Shortest Path First. Open Shortest Path First. Open means it is an open standard protocol, and shortest path first is an algorithm that OSPF uses for best path selection. Like EIGRP uses dual algorithm, right? In the same way, OSPF uses SPF algorithm, shortest path first, right? Shortest path first is an algorithm, and open means open standard. So OSPF stands for open shortest path first. Right? You can say it is open standard protocol. Then after that it is an IGP protocol. Then it is a link state routing protocol. It uses protocol number. It uses protocol number 89. 88 EIGRP used by EIGRP. 89 used by OSPF. It uses two multicast address. Again, this is going to be interesting, like why this routing protocol and how this routing protocol can use two multicast address, EAGRP or reversion 2. You know these two protocols uses one multicast address, right? What is the multicast address of EAGRP, guys?
0.10, sir.
0.10.
224.0.
And OSPF uses two multicast addresses. First one is
0.5 and 6.
0.5 and 0.6.
24.0.0.5. Second one is 224.0.0.6.
6.
Right? We'll see how to, right? For now, you can say 224.0.0.5 will be used by all routers in OSPF domain, by all OSPF enabled router, and 224.0.0.6 will be used by DR and BDR router. Now again, what is DR and BDR? We'll see later. DR and BDR are some special type of router in OSPF. Okay, so DR and BDR are going to listen on this multicast address, and all OSPF enabled routers are going to listen on this multicast address, right? Then it uses SPF algorithm, SPF, shortest path first for best path selection. Means again OSPF is going to build database, and on the database it will run SPF algorithm, then it will calculate the best path, best dot, and it will install that in the routing table for best path selection. Best path selection. Then metric. Metric in OSPF is called cost. Metric is called cost in OSPF. Cost means metric, and formula to calculate cost is cost
Inversely
equals
proportional to bandwidth, 1 upon bandwidth.
reference bandwidth upon bandwidth of link. Reference bandwidth. So we can configure one reference bandwidth. By default 100 Mbps. Reference bandwidth upon bandwidth of link is metric in OSPF. Right? By default reference bandwidth is
100 Mbps.
100 Mbps.
This is for fast Ethernet, right?
No, by default reference bandwidth, not for fast Ethernet. For fast Ethernet, if you want to calculate metric, then you can use this formula. By default reference bandwidth is 100, right? And you know, for fast Ethernet bandwidth is fast Ethernet. सही है क्या स्पेलिंग?
ETHERNET सही है सर.
फास्ट इथरनेट की बैंडविड्थ कितनी होती है? 100 Mbps, राइट?
तो कॉस्ट 1 हो जाएगी सर.
राइट, सो कॉस्ट क्या हो जाएगी?
1.
राइट, सो मैट्रिक फॉर फास्ट इथरनेट लिंक इज गोइंग टू बी 1. इसी तरीके से हम इथरनेट के लिए भी कैलकुलेट कर सकते हैं. व्हाट विल बी द कॉस्ट फॉर इथरनेट? बैंडविड्थ ऑफ इथरनेट लिंक इज 10 Mbps. 10 Mbps. So cost is going to be what?
10.
Right? For serial link, cost is going to be 64, I think.
Sorry.
64. Like this, we can calculate cost or metric for any link in OSPF, right? And sometime you need to change the reference bandwidth as well, because see, if I have giga Ethernet link, if I have 1 gig link, then what will happen, guys? Reference bandwidth 100 Mbps upon bandwidth of link. Bandwidth of link is 1000 Mbps, right? So what value you will get? 0 point something.
But वो 1 लेंगे.
वो one consider करेगा, right? So by default, if reference bandwidth is 100, then OSPF cannot differentiate between gig link and fast Ethernet link. Cost on both types of link is going to be same, right? So in that case, we have to increase the reference bandwidth value, right? 100 is default value. 100 is default value. Your screen is not visible. Is my screen not visible, guys?
It is visible, sir.
It's visible, sir.
Brother, please rejoin if you are not able to see my screen. So these are some basic points about OSPF routing protocol, right? Now let's start OSPF routing protocol from their messages, types of messages in OSPF.
Sir, I have a question. Sir, protocol number हम बताते तो हैं कि 88 89 है, but where do we exactly use it?
Okay, so let's say I have two routers here, R1 and R2.
So can you mute someone who is not speaking?
Good. R1, R2. I have enabled the OSPF routing protocol. OSPF. So this router is going to generate any message of OSPF. Let's say hello message. Hello message, right? So OSPF routing protocol is going to generate hello message at which layer? At layer 3, because OSPF is an layer 3 protocol, right? After that, it will hand over this hello message to IP protocol at same layer. IP protocol is going to add IP header. In IP header, what will be the information? Source IP, maybe 12.1.1.1, destination IP, multicast address 224.0.0.5, and here we have protocol field, right? In the IP header. In the IP header, we have protocol field. So in protocol field, what will be the protocol value, guys? 89.
Okay.
Right? So when router 2 will receive this hello message, how it will get to know that this actual message belongs to OSPF with the help of protocol only? It will say, okay, protocol value is 89 in the IP header. That means actual message belongs to OSPF. It will remove IP header and it will hand over hello message to OSPF routing protocol on router number 2. Clear?
So sir, हम redistribute करते हैं when we redistribute some protocol like we did yesterday. तो उस केस में this is being used to identify the protocol.
उस केस में कभी भी, अब मान लीजिए कि आप ही एक मान लो कि राउटर हो, राइट? आपने कोई मैसेज रिसीव किया, आपको नेटवर्क लेयर पे आईपी हेडर चेक करना है और आईपी हेडर को में एड्रेस वेरीफाई करने के बाद ये पता करना है कि भाई जो एक्चुअल मैसेज है आईपी हेडर के साथ इनकैप्सुलेट हुआ वो कौन सा मैसेज किसको मुझे देना है, राइट? वो ओएसपीएफ हो सकता है, ईएजीआरपी हो सकता है, टीसीपी हो सकता है, यूडीपी हो सकते हैं, कोई भी प्रोटोकॉल हो सकते हैं। तो वो आप कैसे आइडेंटिफाई करोगे? विद द हेल्प ऑफ प्रोटोकॉल। अब प्रोटोकॉल वैल्यू चेक कर, तो आईपी हेडर के अंदर में ये 3 सबसे इंपॉर्टेंट फील्ड होती है, एनटीटीएल, source IP, destination IP, protocol and TTL value. These are most important fields of IP header, right? At each layer we have some information to identify upper layer protocol, right? Like at layer 2 we have type field, at layer 3 we have protocol field to identify upper layer protocol, right? So with the help of this protocol field we are going to identify this hello message belongs to OSPF. If the protocol value is 88, that means this hello message belongs to EAGRP, right? Like that. Clear है?
Clear, sir.
Now,
सर फिर से रिपीट कर दीजिए।
ये लेयर 3 पे आईपी हेडर के अंदर में प्रोटोकॉल फील्ड होती है जो आइडेंटिफाई करता है कि अपर लेयर पे कौन सा प्रोटोकॉल काम कर रहा है। मतलब आईपी हेडर के रिमूव करने के बाद जो पेलोड बचेगा वो पेलोड मुझे किसको देना है, राइट? जब ये राउटर 2 जब ये पूरा मैसेज रिसीव करेगा, राइट, तो सबसे पहले राउटर चेक करेगा डेस्टिनेशन आईपी। ओके, ये देखेगा क्या मैं इस मल्टीकास्ट ग्रुप का मेंबर हूँ, राइट? फिर वो चेक करेगा प्रोटोकॉल, फिर देगा प्रोटोकॉल वैल्यू 89 है। मतलब जो इस आईपी हेडर के अलावा जो इन्फॉर्मेशन बच गई वो मुझे किसको देना है? ओएसपीएफ को। ये बोल रहा हूँ मैं।
कौन सी प्रोटोकॉल को देना है वो प्रोटोकॉल नंबर डिसाइड करेगा।
हाँ बिल्कुल, राइट। ओएसआई मॉडल पता है ना?
हाँ।
नेटवर्क लेयर पे भी बहुत सारे प्रोटोकॉल है। नेटवर्क लेयर अपर लेयर को भी दे सकता है, टीसीपी और यूडीपी को भी, राइट? तो प्रोटोकॉल वैल्यू अगर टीसीपी का है तो फिर टीसीपी के पास चला जाएगा ट्रैफिक, राइट। अगर यहाँ पे मैं प्रोटोकॉल वैल्यू किसका दे दूँ, टीसीपी का, तो ये हेलो मैसेज किसको हैंड ओवर कर देगा, राउटर टू टीसीपी प्रोटोकॉल को। पैकेट फ्लो का पार्ट है ये, पैकेट फ्लो का। ओके, लेट्स स्टार्ट OSPF फ्रॉम देयर मैसेजेस। टाइप्स ऑफ मैसेजेस, types of messages in OSPF. Anyone have idea about message type, guys, in OSPF? How many types of messages are there?
सर एक तो हेलो ही होता है।
हाँ, एक तो हेलो ही होता है, ठीक है। और कोई आइडिया किसी को?
LSA message, LSU.
करेक्ट।
सेपरेटली सेट एक्नॉलेजमेंट।
Okay, so first message is called type 1 message. Type 1, type 2, type 3, type 4 and type 5. How many types of messages are there in OSPF? 5 types of messages are there in OSPF. 5 types of messages are there. Type 1 message is hello message. Type 2 message is DBD message, database description. Type 3 message is LSR, link state request. Type 4 message is LSU, link state update, जो कि आपका एक्चुअल नेटवर्क इंफॉर्मेशन कैरी करेगा, राइट। एंड टाइप 5 मैसेज इज LSAC, एक्नॉलेजमेंट, लिंक स्टेट एक्नॉलेजमेंट। ये इतने टाइप के मैसेज होते हैं उस पे ऐप में। क्लियर?
Sir, LSR means
लिंक स्टेट रिक्वेस्ट।
instant request. DBD.
DBD
Database.
stands for database description,
Okay.
right? Again, what is the use of hello message? Same like EIGRP. Hello message is similar like EIGRP hello message, used to discover,
नेबर।
yes, discover neighbor and keep alive. Neighbor and keep alive. Keep alive, right? OSPF router sends hello message on which address? On which multicast address? 224.0.0.5. And unicast in case of static neighborship.
.9.
Unicast in case of static neighborship, right? In dynamic neighborship, it will send on this multicast address, similar like EIGRP, right, guys? Similar like EIGRP. In EIGRP also, in a static neighborship, hello message will be sent on unicast address. In dynamic neighborship, it will be sent on multicast address, right? What will be the content in hello message? Content. Contents of hello. Again, version, type field, length, router ID. Router ID. Then subnet mask. Subnet mask. Hello time and date time. Hello time and date time, or you can say date interval. Priority. Priority will be there. Then DR router ID. DR router ID. We'll discuss all the things, don't worry. BDR router ID and neighbor router ID. Neighbor router ID. These are the contents of hello message, and many more contents are there, but these are the important information like authentication type after configuring authentication data. Those information will be also there. But what are the neighborship parameters? These are the content in hello message, but what are the parameters, hello parameters? How to router can become neighbor?
So they should have, first of all, same subnet.
Neighborship parameter. Yes, first of all, router ID must be unique. Router ID must be unique. Now here we will discuss router ID also in detail. Don't worry. But router ID is nothing but the unique identity of router, identification of router, and it should be unique always, must be unique. Second thing, hello time, hello and date interval must be same. This is not the requirement in EIGRP. In EIGRP, hello time can be different, but in OSPF, guys, hello time and date interval time should be same on both router. Then only it will form neighborship. Otherwise, there will be issue. Then subnet mask must match. Subnet mask must match. Then MTU must match. MTU must match. MTU is also requirement in case of OSPF neighborship, right? Area ID must match. Area ID, right? And network type also must match. Network type. We will discuss about these things like area ID, network type later. Okay, so this is OSPF neighborship parameters, right? So for now you can say subnet mask, hello time, date time and MTU and area ID must be same. Then only two router can become router, sorry, neighbor, right? Now let's understand router ID. Router ID. What is router ID? It is 32 bits decimal value represented in IPv4 format. IPv4 format, right? OSPF uses unique identification to represent their database called router ID, right? So what is the use of router ID in OSPF? OSPF router is going to represent their database with the help of router ID. Like a router, let's say there is one router R1 using router ID what 1.1.1.1. right? So this router is going to share their database to other routers with their router ID 1.1.1. That is the identification of their database, right? In the same way, router 2 will have their own database, and how they will represent their database with the help of their own router ID, right? And router ID should be unique, then only neighbors will form. Clear? Now second thing about router ID is how to configure router ID on router. So see guys, there are two methods to configure router ID, right? Either we can configure manually. Manually we can tell to router, yeah, your router ID is 1.1.1 or 10.10.10, right? Or second method is, if you will not define manually, then router will elect router ID dynamically. Now question is how router is going to elect router ID dynamically, right? So guys, for dynamically, first of all, router is going to check loopback, right? Whatever IP address is running on loopback interface, that will become router ID. But what if more than one loopback exists on the router? Then highest IP address on the loopback will become what? Router ID. Highest IP address of loopback interface will become router ID. If loopback does not exist on the router, then router is going to check interface IP address, right? Again, highest interface IP address will become router ID, right? But if physical interface is also not configured and you have enabled the OSPF, let's say there is no loopback, no physical interface, but you have enabled the OSPF. In that case, router is going to elect 0.0.0.0 as router ID, right? But always keep in mind, whenever we will enable OSPF on the router, it will elect router ID first. This is the first task of router after enabling OSPF, that is electing the router ID. Someone is saying allow me. Just a minute. Yes. Clear? Any question till here? This is first message.
Sir,
Yes.
सर इस हाईएस्ट टाइप एड्रेस मतलब क्या है सर? हाईएस्ट
हाईएस्ट
टाइप
IP
एड्रेस
एड्रेस मतलब देखिए, आप एक राउटर लेता हूँ यहाँ पे, ऐसे नहीं होगा, राइट? यहाँ पे कुछ दो लूपबैक हैं, लूपबैक 1 IP address
Yes, sir.
1.1.1.1, loopback 2 IP address 2.2.2.2. So what will be the router ID?
अभी 2.2.1
Highest IP address, right? This IP address
Oh.
is greater than this IP address, right? 1.1.1.
yes sir हाँ सर thank you sir cut.
Okay. If there is no loopback, then physical interface IP address, right? Sometime interview is asking question from this topic, like they can draw this diagram. There is one router, there are two interfaces, F0/0, F0/1, F0/0, and F0/1. F0/1. They can say here IP address is 10.1.1.1. Here IP address is 20.1.1.1. I have enabled the OSPF routing protocol on this router. What will be the router ID?
20.
20.1.1.1.
20.1.1.
Then they can ask you, there is one loopback also. Configure. And IP address on loopback interface is 1.1.1. Then what will be the router ID?
And it's gonna be
20.1.1.1.
1, not 20.
No,
If loopback
1.1.1.
exists, yes, 1.1.1.
That time it's taking a loopback, sir.
Yes. If loopback
Okay.
exists, then loopback. First it will check loopback. If loopback does not exist on the router, then only it will check physical interface.
Okay.
Loopback means local IP in the network, correct?
Management.
Loopback
type
means
of
virtual
sensor.
interface, na brother?
Management type.
Okay, virtual interface.
Yes.
Usually, I think it is management IP, right?
Loopback is used for self-testing.
Self-testing means 127.0
No,
dot
no,
1, right?
that is different thing. That is different thing, brother. That is reserved for loopback, right? But on the router, generally we are configuring 1.1.1 or 2.2.2, 10.10.10 like that.
Okay.
Sir,
Mhm.
just I have one small question. If we configure the manual router ID, for example, 1.1.1.1, just I would like to know, it's a 32 bits decimal value. So it will not conflict with the other routers IP address, right? It's just only
No,
router
no.
ID.
First is manual configuration. Manually, if you have configured, then it will not check dynamically. It will not
Yes, sir.
select
That's I
dynamically.
understand, sir. What I'm asking, if we configure the manual router ID, means this only router ID, right? This is not IP
Manually,
address.
I can say 10.10.10.10 is your router ID.
Okay.
Right, so it will use this ID as a router ID.
Sir, my question here, 10.10.10.10, this subnet already available within this OSPF network somewhere.
Doesn't matter that is available or not. Any IP
that's
address
what
you
I'm
can
asking, sir.
configure.
Okay,
Right?
sir.
Maybe
That's what
that
I'm
is
asking.
So this
configured on the
address only
router.
for this address used for only for router ID, not for ping or any network
No, that is
related
not
things.
routable. We cannot ping that IP address. That is just a identification of database. See, if you have something, right, and you are going to share with your friend like one database, right? So multiple friends are sharing their own database, so definitely there should be some representation like through which we can differentiate the database of your and your friend, correct? So this is also one just a ID to represent their database. Router 1 is going to build one database and it will represent their database in OSPF domain with their router ID.
Sir, the router ID has to be unique, or can we have same router ID on multiple routers?
No, it should be unique. That is OSPF neighborship parameter. Otherwise, OSPF neighborship will not come up. Router ID must be unique in the OSPF domain.
Sir, if we have a full mesh topology, and if the router ID is same, what would be the impact?
You will get error that duplicate router ID. OSPF neighborship will not come up.
Okay.
Right? Like remember, neighborship parameter in EIGRP. AS number must match. If AS number will match, then only two router will become neighbor. In the same way, here OSPF, in the OSPF it is going to check first router ID. Router ID must be unique. Then hello time and date time must be same. Submit mask must be same. MTU must be same. Then only two routers can become neighbor.
Network type has to be same.
Yes. So first type of message, hello message, which is used to discover the neighbor and keep alive. Right? Router will send hello message on this multicast address and on unicast in case of a static neighborship. And we have seen the content of hello message and neighborship parameters as well as router ID. Now before talking about type 2 message, DBT message, let me tell you about OSPF neighborship state.
Sir, I just have a question. In in what case will the router select 0.0.0
If
as the router
if
ID?
you have not configured the router ID manually, as well as there is no loopback configure, there is no IP address configure on the physical interfaces. In that case, router will elect router ID what 0.0.0. For an example, GNS3. भाई थोड़ा सा जल्दी लोड ले लो यार, इतना टाइम मत लगाओ, बहुत कुछ है OSPF में. So if I will enable OSPF over here on this router, what will happen? Router ID will be what? 0.0.0, because there is no any IP address, there is no loopback, nothing is there.
तो बट प्रोसेस तो अपने को इनिशिएट करना पड़ेगा ना OSPF राउटर
कॉन्फ़िग
OSPF
थी, हमने डायरेक्ट बोल दिया राउटर OSPF प्रोसेस ID 1, so IP protocol. What is router ID?
0.0 ठीक है.
राइट. अब यहाँ पे अगर मैं एक लूपबैक क्रिएट कर दूँ, इंटरफेस लूपबैक 1 एंड से IP एड्रेस 1.1.1.1 255.255.255.0, so IP protocol. What is router ID?
1.1
राइट. अब यहाँ पे इसको मैं मैनुअली बोल दूँ राउटर OSPF प्रोसेस ID 1 एंड राउटर ID 10.10.10.10, so IP protocol. What is router ID?
10.10
Right? But एक बार neighborship up आ गई, once a router have discovered the neighbor, after that you are not allowed to change the router ID.
correct.
Right? Because see, I have already shared my database with my router ID, right? So after exchanging the database, you cannot change the router ID. Clear? So we'll see those things later, don't worry.
So database कब exchange होता है? Hello पे you mean after hello exchange is done we cannot change the router ID?
So देखो टाइप, ये मैसेज है ना, मैंने क्या बताया,
सेकंड मैसेज.
अपडेट मैसेज कहाँ पे है? यहाँ पे. अभी तो हम इसी मैसेज पे है ना, आते हैं सारे मैसेज पे वन बाय वन. अभी आपको समझ में आएगा डेटाबेस कब एक्सचेंज होगा. ओके, नेबरशिप समझ में आया? हाउ राउटर्स आर गोइंग टू बिकम नेबर?
Yes, sir.
R1, R2, both router will share hello message after enabling OSPF. Both will check parameters. If parameters will match, both router will become neighbor. Now, this is not like EIGRP. This is not like EIGRP. Two router will directly become neighbor. Here we have some states. Routers are going to go through some states to form neighborship, right? So let's understand those states first. After that I will again come on messages. So OSPF neighborship states, very important topic. States, VVI. First state is down state, second state is init state, third state is attempt state, but attempt now I am ignoring. Third state is two-way state, fourth state is X start state,
exchange.
X start, fifth one is exchange, sixth one is loading, and
Then
seventh one is
full.
full. So here routers are going to become neighbor, right? There are two types of neighbor in OSPF. One, neighbor without adjacency, and second, neighbor with adjacency. If neighborship is in full state, that means we have neighbor with adjacency. एडजेसेंसी. अब आप बोलोगे नेबर विथ एडजेसेंसी और विदाउट एडजेसेंसी मतलब क्या हुआ? नेबर मतलब आप जानते हो ना, मेरे घर के बगल वाले को क्या बोलते हैं हम? नेबर, राइट? आप देखते हो कुछ नेबर कैसे होते हैं कि जिसके साथ हम बात भी नहीं करते हैं, कभी हार्डली बात करते हैं. कुछ नेबर कैसे होते हैं जिसके साथ हम खाना भी एक्सचेंज करते हैं, है कि नहीं है? तो उसी तरीके से OSPF में कॉन्सेप्ट है, राइट? विथ सम नेबर्स राउटर आर गोइंग टू एक्सचेंज द डेटाबेस, विथ सम नेबर राउटर्स आर नॉट गोइंग टू एक्सचेंज द डेटाबेस, right? Neighbor without adjacency, if there is no adjacency, that is only the neighbor will never exchange the database. And OSPF, neighbor in full state means with full adjacency will always exchange the database, right? So some neighbor will be till two-way state, that is only the neighbor, that is only the neighbor, but we will never exchange the database if neighborship is in till two-way state. If neighborship is in full state, that means database is already exchanged. That means database is already exchanged, right? Let's understand all the states one by one. Down state, what is the meaning of down state?
सर इसमें एक क्वेश्चन आता है कि व्हाट इज द डिफरेंस बिटवीन नेबर एंड एडजेसेंट.
सो वही तो बताया, नेबर मतलब कि नेबर है, मेरे साथ कनेक्टेड है, हमने नेबर फॉर्म कर लिया, लेकिन उसके साथ मैं डेटाबेस एक्सचेंज नहीं करूंगा. और एडजेसेंस मतलब डेटाबेस ऑलरेडी एक्सचेंज हो चुका है,
मतलब फुली सिंक्रोनाइज्ड है दोनों.
फुल्ली सिंक्रोनाइज्ड है दोनों, राइट? नाउ R1 R2, R2. On router number 1, I have enabled the OSPF. Here IP address is 12.1.1.1. Here IP address is 12.1.1.2. On router number 1, I have enabled the OSPF routing protocol. OSPF is enabled over here. But I have not enabled OSPF on router number 2 till now. So what will happen? Router 1 will be sending hello message, but it will be not receiving any hello message. Yes or no?
Correct.
It is sending hello message, but it is not receiving any hello message on this particular interface. Let's say app0/0, right? So a state of this interface will be considered as
Down.
A state of this interface will be considered as down. Means a interface or a router interface is sending hello message but not receiving any hello message on that particular interface.
The state of R1 interface will be considered down.
R1 interface, yes. Till now I have not enabled OSPF on R2. So where is the state on R2? There is nothing like that. Even OSPF is not enabled on router number 2, right? So we cannot talk about the state on router number 2. R1 F0/0 state, neighborship state is down. Why? Because it is not receiving any hello message here. Clear? In a static neighborship, guys, you will see attempt state also, right? But in dynamic neighborship, we don't have attempt state. Clear? Init means what? Initialization. When router 1 will receive hello message on F0/0, state will move to init. Init state means initialization. Initialization of OSPF started.
Means
Right?
you can say acknowledgement of hello from R2 side would be.
Not acknowledgement. Hello message from router number 2. DC. Router 1 is trying to discover neighbor on F0/0.
Correct.
Right? But when it will discover, when it will receive any hello message, correct?
Correct.
So until and unless router 1 have not received the hello message, it will consider their interface as down. Means OSPF is down on this particular interface. Once it will receive the hello message, initialization will start. State will move to init state. right? And now router will start checking the parameter. When router 1 will receive hello message from router number 2, it will check parameters. Hey, let me check R2 have unique router ID or not. R2 is using same hello interval and date interval or not. Getting my point? After that, guys, next thing. See what I told you, in the hello message there will be neighbor router ID. Neighbor router ID. First of all, in the hello message of R1 there will be their own router ID. My router ID is 1.1.1. Here also my router ID is 1.1.1. 1.1.1. Right? When router 2 will send hello message, first hello message, again router 2 will send what? Their own router ID. That okay, hello message, this is my hello message, and my router ID is 2.2.2.2. Right? Here I am expecting router ID 1.1.1, and on router number 2 I am expecting router ID 2.2.2. Clear till here? Now these routers are going to check bidirectional connectivity, right? Router will check their router will try to find their own router ID in the receiving hello message, right? Now see, now router 1 know that on F0/0 a router is connected whose router ID is
2.2.
right, and router 2 also knows that on this interface I am receiving a hello message from a router whose router ID is 1.1.1. So in the next hello message of router 1 there will be their own router ID as well as neighbor router ID. At my router ID is 1.1.1.1 and my neighbor router ID is 2.2.2. And once router 2 will find their own router ID in the hello message, state will move to 2-way. Right? In the same way, when router 2 will send next hello message, router 2 is also going to send their own router ID as well as neighbor router ID. My router ID is 2.2.2.2. My neighbor router ID is 1.1.1.1. Right? Here also state will move to 2-way. Till here, any question?
So that means after hellos are exchanged in the first step in init state, sir. So one more hello would be sent for sharing the router IDs to each
After
other.
receiving hello message of router 2, in the next hello message, router will share neighbor router ID also. And whenever router found their own router ID in the receiving hello message, state will move to 2-way.
Sir, all this communication is being done on hello messages only?
Till here we are talking about hello message only. Right? See, how many states are there? Down,
7.
init, 2-way, X start, exchange, loading, full. In exchange, loading, X start, we are going to discuss next types of messages as well. Right? Till now we are here, till 2-way. Till 2-way state, only hello message will be exchanged. No any other messages are exchanged till now. Clear?
Okay.
Now, in 2-way states, routers are going to perform some task. At this state, routers are going to perform some task. Task number 1. Router is going to check bi-directional connectivity. Guys, how EIGRP routers check bi-directional connectivity?
Update messages.
Which update message?
Null update.
Null update message, right?
Correct.
In OSPF, in 2-way state, bidirectional connectivity will checked. Second task, what I told you, DR and BDR. So DR and BDR router election will happen. Election happened, right? don't worry about what is DR and BDR. We will discuss about DR and BDR, but what I told you, DR and BDR are some special type of router in OSPF, right? And at which state DR and BDR election will happen? In two-way state. Which state? Two-way state. After that, state will move to X start. The next state. X start. In X start state, routers are going to exchange type 2 message. Exchange type 2 message. What is type 2 message? DBD. Type 2 message is DBD, database description. Now question is, what is database description? Let's take one example of a restaurant. You want to eat burger, right? So you went to a restaurant, and in the restaurant, guys, tell me, first you are going to check the menu card, correct? Menu card means what are the food available in that restaurant, correct? Number of foods are there in the menu card. Are you going to order all the foods? No. We are going to order hardly 1 to 2 food. So that menu card is what? Description. That is even not the actual food. That is just a description of available food. And then whatever you are going to request, they are going to deliver, right? Let's say I am going to request burger, then they will give me the burger. So description is exactly same like menu card, right? Let's say here I have two router. I have two router R1 and R2. A router 1 have some prefixes. Some prefixes are directly connected with router number 1. Let's say X network, X, Y and Z. These are connected networks, or A, B, C. These three networks are directly connected with router number 1, and X, Y, Z, these networks are directly connected to router number 2. So router 1 is not going to share this network information, but it is going to send one header of this network information. That brother, router 1 is going to tell to router 2 that brother, I have X, A, B, C network. I have A network, B network and C network. This is just a header, description, not the actual networks. Means detailed informations are not there. Just a header. Router 2 is also going to send header. Description of database. That in my database there is X network, Y network and Z network. Database description. This is what database description. At this particular state, with the help of description, routers are also going to exchange the sequence number. Routers are also going to negotiate the MTU size. So what I told you, MTU is also OSPF neighborship parameter. If MTU will not match, the neighborship will stuck in which state?
X start
state, because here only MTU negotiation will happen, right? Then master and slab router election will also happen here. Again, what is master router, what is slab router will discuss. Master router will initiate exchanging database first. Master router is the router who will initiate exchanging database first, right? Slave router will wait. So election will happen at this state. If you want to ignore the MTU, you can ignore it as well. We will see those all things later. Don't worry.
सर सीक्वेंस नंबर क्या आप कह रहे थे? सीक्वेंस नंबर
सीक्वेंस नंबर ये जीआरपी में आपने पढ़ा?
हाँ,
क्या होता है? मैंने आपको कोई इंफॉर्मेशन दिया सीक्वेंस नंबर 10 से और फिर से एक अपडेट मैसेज भेजा थोड़ी देर के बाद सेम सीक्वेंस नंबर से, तो क्या आप चेक करोगे अपडेट मैसेज?
एक्नॉलेजमेंट आना चाहिए।
नहीं, आप ये देखोगे ना कि भाई अगर मैं हायर सीक्वेंस नंबर से अपडेट मैसेज रिसीव कर रहा हूं, मतलब उसमें अपडेटेड इंफॉर्मेशन है। सेम सीक्वेंस नंबर से अगर मुझे
ओके, गॉट
अपडेट,
इट। यस यस यस, अगर नहीं आया तो फिर आई विल नॉट चेक।
right, so it is used to check that my database is updated or not,
नॉट ओके ओके।
right? And whenever change will occur, sequence number will be incremented by 1. Correct? And even these are empty DBD. These are empty DBD, database description. Empty DBD. In which state? In X start. After exchanging empty DBD, exchanging the sequence number, negotiating the MTU and performing the election of master and slab, state will move to exchange.
सर एक क्वेश्चन बिफोर दैट। सर जब हम नेटवर्क को एडवर्टाइज ही नहीं करेंगे ओएसपीएफ में, तो सर डीबीडीज बेचने का मतलब क्या है?
हमने एडवर्टाइज कर दिया है ना नेटवर्क को, ABC और XYZ हमने एडवर्टाइज कर दिया है OSPF में।
ओके,
है ना? अगर आप इस ये सारे नेटवर्क मान लीजिए यहाँ पे नहीं भी है, तब भी राउटर अपना एक डेटाबेस तो बनाएगा ही। जो 12 का नेटवर्क है वो तो है उसके डेटाबेस में, है ना? अभी आपको क्लियर हो जाएगी चीजें, जस्ट वेट फॉर सम मोर टाइम।
इंटरफेस का होगा एग्जैक्टली।
राइट, अभी हम ये भी देखेंगे ना कि डेटाबेस कैसे राउटर बिल्ड करता है, तो चीजें क्लियर हो जाएगी। डन। नेक्स्ट स्टेट इज exchange state. Now in exchange state, router will send header of LSA. Header of LSA. Router will exchange header of LSA. Now let me tell you about LSA. What is LSA? यहाँ पे बताता हूँ LSA.
Sir, in exchange state, which router will send this LSA message first, master or slave?
Both router. What is LSA?
सर
Link
एक्सटार्ट
state.
में क्या बताया था आपने? एक्सटार्ट में क्या बताया था आपने? विच राउटर विल सेंड डीबीडी फर्स्ट?
No DBD. Which router will send their database first? LSU update message, right? For that, master and slab election happened here, right? Let's say R1 became master router, so R1 is going to send database first. Okay, first understand what is LSA, link state. LSA stand for link state advertisement. Advertisement, right? Link state advertisement means a state of link. This is actually database of router. Let's say I have one router here, R1, connected with two interfaces, fast Ethernet 0/0 and fast Ethernet 0/1, right? So a state of these links are called what? LSA. Let's say here my subnet is 10.1.1.1/24. Here my subnet is 20.1.1.1/24. So router 1 is going to create their database. In the database, it will store what? LSA. LSA means a state of link. A state of link means, let's say I have one link, link number 1, link 1, where which network is running? 10.1.1.0/24. What is the cost on this link? 10. Like these types of information, right? Then I have one another link, link number 2. Which network is running there? 20.1.1.0. What is the cost there? So the detailed information of link is called a state of link, that is called LSA, right? And router, OSPF router maintain database. In database it store LSA, right? And in the exchange state it will only share the header, right? It will not share the detailed information of link. It will only share that I have this network information. I have 10.1.1.0. In the access start it have sent the empty DVD. There is nothing. But in the exchange state, routers are going to send header, right? Now router 1 know that router 2 have XYZ, and router 2 know router 1 have ABC. Correct? Correct, guys? So now routers are going to request for the detailed information for LSA, right? So a first state here is exchange. In exchange, both routers have exchange the header, LSA header.
Header means a network only, right?
Yes.
Not the metric and not the
Yes.
cost.
Right? Means now interviewer can ask you this question: in which state type 2 message will exchanged? In which state type 2 message will exchanged? Tell me.
Start में.
In X start state and exchange state. In both state type 2 message will exchange. X start and exchange. After that, after exchanging the header, state will move to loading. And guys, everything will happen in loading state only, right? Loading means routers are going to send what? LSR, link state request. In the response of LSR, router will send what? LSU. And OSPF is an again reliable protocol. So after receiving update message, it will send acknowledgement LS ACK. And once database will be exchanged, state will move to full. So full means what? Everything is already exchanged. Now tell me, type 3 message, type 4 message and type 5 message will be exchanged at which state?
Loading.
Loading state. In full state, nothing is going to be exchanged. Everything is already exchanged. Now we have full adjacency.
Established.
Yes. Neighborship is established. So all types of messages and neighborship states. Clear? Now we are going to discuss LSA in detail. There are many types of LSA. You need to learn 8 types of LSA here. Router LSA, network LSA, summary LSA, ASVR LSA, external LSA, right? And this is the main concept of OSPF routing protocol. Just give me 1 minute. 1 minute, guys.
सर लिंक स्टेट रिक्वेस्ट में क्या होगा और एलएसयू में क्या होगा?
लिंक स्टेट रिक्वेस्ट में जैसे आपने रेस्टोरेंट में जाके क्या किया, मेन्यू दिया रेस्टोरेंट वालों ने, आपने ऑर्डर किया, तो वो क्या हुआ, रिक्वेस्ट करना कि भाई ये हेडर में तो मैंने देख लिया कि तुम्हारे पास बर्गर है, अब मुझे बर्गर दे दो, राइट। तो मैंने रिक्वेस्ट किया, फिर बर्गर आएगा मेरे पास। सो ये रिक्वेस्ट वाला फंडा किस स्टेट में हो रहा है, लोडिंग स्टेट में, राइट। और जो मेन्यू कार्ड आपके पास आया था हेडर, वो किस स्टेट में आया था, एक्सचेंज स्टेट में। समझ में आया?
जी।
एक बार यहाँ पे टोड लैमने वगैरह में आप देख सकते हो वैसे, अगर देखना चाहते हो तो। पर देख लेते हैं क्या है। OSPF DND stand for Dynamic Neighborship Discovery। कहाँ पे लेके आ गया यार ये? भाई
सर राउटर एलए में ही चल पड़ा सर।
हाँ वो भी वही ठीक है नहीं। राउटर
वो
LA में
थोड़ा
ही चलता
शॉर्ट,
है।
वो शॉर्ट में ज्यादा अच्छा बताएगा।
OSPF neighbor state, ये यहाँ पे है डाउन, indicate that no hello message has been heard means received from the neighboring router। समझ में आ
हमने
गया?
भेजा वहां से नहीं आया।
हाँ, हर्ड मतलब रिसीव नहीं हुआ है कोई मैसेज। जब
करेक्ट।
तक हेलो मैसेज रिसीव नहीं होगा तब तक स्टेट कैसा रहेगा, डाउन, राइट। इन इट इंडिकेट अ हेलो पैकेट हैज बीन हर्ड फ्रॉम द नेबर बट टू वे कम्युनिकेशन हैज नॉट बीन इनिशियलाइज्ड मीन्स router have not seen their on router ID in the hello message, right. Two way indicate that bidirectional communication has been established means router have seen their on router ID in the hello message. Even I can show you by capturing the link between two router also, like in the first hello message you will see there is router ID of the router only, right. But in the second hello message you will see the neighbor router ID is also there. X start indicate that the router is preparing to share link state information. Master and slab relationship are formed between two routers. Okay, थोड़ा सा उतना डिटेल में नहीं लिखा है। Indicate that routers are exchanging database description DBD in the exchange content। ठीक है, जो मैंने आपको बताया वही ज़्यादा बेटर है इसे समझने के लिए, ठीक है। बाकी
Sir,
वही
you
सब
have
चीज़-
sir, you have mentioned in the class empty DBD which is on X dot state,
Correct.
but here it mentioned DBD is on the exchange.
So that's why I'm saying na, it is not discussed in such detail,
Uh-huh.
right. To verify it, what you can do, you can connect to router and you can capture the link R1 R2, 12.1.1, 12.1.1.2, router ID over here is 1.1.1.1, router ID over here is 2.2.2. विजिबल तो है ना टोपोलॉजी? जूम कर दूं क्या?
विजिबल
करे कॉन्फ़िगर OSPF?
यस
उससे पहले लिंक को कैप्चर कर लेते हैं. थोड़ा एक मिनट पानी पी लूं. लिंक पे कोई ट्रैफिक क्यों नहीं है? पोर्ट्स डाउन है
राउटर के बाय डिफॉल्ट एडमिन डाउन है
जी. इंटरफेस F0/0 नो सर्ट IP address 12.1.1 255.255.255.0. router 2 config T interface F0/0 no cert IP address 12.1.1.2 255.255.255.0 ping 12.1.1.2. ठीक है, ट्रैफिक भी है लिंक पे, सब कुछ ओके है. Now we have multiple options to enable OSPF on the interface of router. Guys, you know routing protocol works on the interface of router, not on the router, right? So we can enable OSPF on interface basis as well, and in global configured terminal mode as well, right? For now here I am going to enable globally router OSPF 1 router ID 1.1.1 and network 12.1.1.0 wildcard mask 0.0.255 area 0, right? It will start sending hello message. Are you able to see hello message of OSPF?
Not yet.
Yes.
Yes, no.
On what address?
0.5
Source exit interface
4.1.
IP address, right?
Yeah.
If you will open this hello message, see what are the content there. Header is there, OSPF hello packet is there. Under header what informations are there? Version, message type, length, router ID, area ID, checksum, authentication type, authentication data. These are the information inside the header. Inside the packet, subnet mask, hello interval 10 second, priority 1, we will discuss about priority later. Dead interval 4 time of hello interval. In OSPF dead interval is 4 time
40.
of hello interval, 40 second, right? DR router, BDR router 0.0.0 means not discovered till now. So these are the information inside the hello message, and router 1 is only sending hello message. It is not receiving any hello message till now, right? Now let me
So,
take you
sir,
to
here you have, sir, here you mentioned router space OSPF space 1. What is the purpose of this one? What is this?
this one. This is
Ah,
process ID, brother. This is locally significant. We can configure same or different on both router, but on a single router we can run more than one OSPF process.
So
On a
any
single-
number we can put.
Any number.
Okay.
so
We
this
can
no,
run
this
more
no,
than
no.
one process on single router, right? So process ID is used to identify the process of OSPF, right? I can run OSPF process 1, 2, 3 like that.
So each router it has different process ID. This no problem.
No,
Can have.
this is
Yeah.
locally significant. It can be same also, it can be different also. OSPF and C process ID. It is 16 bits value, so range is 1 to 65535. Right?
Got it.
Here also I am going to say 1, or you can configure 10, anything, right? It's not matter. Then router ID I am saying 2.2.2.2 and network 12.1.1.0 wildcard mask 0.0.255 area
0.
0, right? Can I hit enter?
Yes.
Once I will hit enter, router 2 will send
Hello.
hello.
2R1.
Guys, before that, let me show you the hello message again, which router 1 is sending. There is information of their own router ID. Their own router ID is there, but there is no any information of neighbor router ID. Yes or no? Neighbor router ID is not there, correct?
Sir, but
Now,
why it is yeah this point?
this
अपने
is
आप को डीआर क्यों कर रहा है?
अरे तो अब प्रधानमंत्री का इलेक्शन होगा और कोई खड़ा ही नहीं हुआ इलेक्शन में, तो जो एक खड़ा है वही बन जाएगा ना प्रधानमंत्री. तो इसकी
Okay.
टाइमर होती है 40 सेकेंड. अगर 40 सेकेंड तक इसको हायर प्रायोरिटी से कोई हेलो मैसेज नहीं मिला तो अपने आप को डीआर डिक्लेयर कर देगा. एक बार डीआर बन गया तो बन गया. डीआर बीडीआर के
हेलो
बारे में हम लोग डिटेल में डिस्कस करेंगे अभी आने वाले टाइम
हेलो
में.
हाँ जी यस बोल
यस सर. तो मैं वियतनाम टीम से वही चेक करवा रहा था सर.
हाँ
आपका वीजा के लिए सर अभी फिलहाल के लिए मैम से मेरी वही बात कर रही थी.
हाँ
हम लोग को वीजा के लिए भी हम शायद से मुझे कल ही अप्लाई करवाना पड़ेगा सर.
ओके
कि मैनेजमेंट से वही बात की, अगर हम आज नहीं करते हैं
डियर
तो
राकेश प्लीज म्यूट
ये कल ही जाएगा.
Wait,
तो
नहीं, वीजा से क्या
wait,
बोल रहा
wait a minute. Let me.
है? अरे यार,
वीजा हो गया.
वीजा प्लान होना चाहिए था आज.
थोड़ा सा पूरी बात तो समझे भी नहीं है, बीच में आप लोग रोक दिए. कोई नहीं. राकेश इज ए गुड गाइस. ओके, अब मैं यहाँ पे करता हूँ एंटर. देखो सारे
Sir, this
मैसेज.
area number also should match.
Yes, area
Yes,
should also
area
be
should be.
same. Now see where is the first hello message of router 2?
This one.
This is the first hello message of router 2. After receiving first hello message from router 2, see the second hello message of router 1, right? In this hello message, you can find what?
Router ID of
Router
2.
Right? Now router 1 is sending this hello message to router 2, and in that hello message there is router ID of router 2. The bidirectional is checked. Bidirectional connectivity is checked. Done. And after receiving the hello message from router number 1, router 2 is also going to send what? Neighbor router ID. After that, are you able to see database description? Who is sending database description? 12.2, 12.1.
सर राउटर 2 ने हेलो नहीं भेजा सर विद नेबर आईडी.
राउटर 2 का हेलो मैसेज यहाँ पे है ना, ये रहा है ना, ये देखिए ना.
डीबीडी से पहले ही आ जाएगा.
अरे तो
बाद में
10 सेकेंड पे भेजता है ना हेलो मैसेज.
ओके.
अब इस पे वायर शार्क पे ऐसे कैप्चरिंग भी बहुत है.
चलिए डीबीडी देखते हैं.
डीबीडी सबका भी थोड़ा सा देखिए, ये 4-5 बार दिखा रहा है ना, थोड़ा बहुत इधर उधर रहता है इसमें कैप्चरिंग में. ओके.
और इसमें सर पहले 2 ने भेज दिया 1 को.
हाँ, यहाँ पे हुआ कैसा होगा, पहले ये हेलो भेज रहा था अकेला. राउटर 1 was sending hello message, right, with their own router ID 1.1.1.1, right? After some time, router 1 have received one hello message from router number 2 with their own router ID 2.2.2, right? Then in the next hello message, router 1 have sent what? Their own router ID as well as
नेबर आईडी.
their neighbor router ID, right? Now, router 2 also know the router ID of their neighbor. So in the next hello message of router 2, it will send active neighbor ID. 2.2.2 is my router ID and my neighbor router ID is 1.1.1.1, right? And in all future hello message, both information will be there. ओके. आप जो बोल रहे हो ना, ये क्या बोलते हैं राहुल, वो थोड़ा सा देखिए. ये ओएस राउटर 2 का पहला हेलो मैसेज नहीं है जिसमें नेबर एक्टिव नेबर राउटर आईडी भेज रहा है. ये वाला हेलो मैसेज में ही भेज दिया होगा, ये देखिए। अच्छा, यहाँ पे नहीं
खाली
भेजा है, खाली है, यही है। फिर तो और तो कोई हेलो मैसेज नहीं है ना, यही है
उसके
फिर।
बाद में डीपी
फिर
डीपी
हेलो पैकेट से फिल्टर, वी कैन फिल्टर विथ हेलो पैकेट ऑप कोड डाल के।
हाँ, ऐसे हेलो भी लिख सकते हैं, यहाँ पे ऐसे फिल्टर हो जाएगा, या OSPF फिल्टर कर सकते हैं।
OSPF डॉट ऑप कोड।
हाँ
तो
ठीक
एक बार
है। DBD, डेटाबेस डिस्क्रिप्शन। डेटाबेस डिस्क्रिप्शन के अंदर में क्या इन्फॉर्मेशन है? अगेन हेडर डिस्क्रिप्शन। हेडर के अंदर तो सेम इन्फॉर्मेशन वही, राउटर आईडी, एरिया आईडी, चेकसम, ऑथेंटिकेशन, वो जो हेलो में था, हेलो हेडर में। वी हैव सिमिलर इन्फॉर्मेशन हियर, एंड इन द डिस्क्रिप्शन is there anything, guys? Is there
ये
any
सब
network
खाली है।
information?
So
No,
empty DPD is this.
this is empty DBD, right? And master and slab routers informations are there.
What is OBR sync, e-sync?
Where is OBR?
I think 0BR. Yeah.
OOBR,
OOBR.
resync, not set. DB description.
Yeah, first
DB description.
DB description initiate.
Third.
Init, first one, 0. First RINMS, first one, yeah.
This
And
one.
this one,
This,
first one.
इसके
first
नीचे,
one.
इसके नीचे.
ये
हाँ हाँ.
ये सब फ्लैग है इसका,
Okay.
DBD का। इस सबको अभी थोड़ी देर के लिए इग्नोर करिए।
Okay.
ये empty DBD है, right? And here is the database description।
ये भी खाली है।
हाँ, तो अभी तो कोई प्रीफिक्स ही नहीं है ना, तो खाली ही रहेगा वो, कुछ नहीं रहेगा।
सर ये अपनी भी नहीं करेगा बेसिकली जो हम बात कर रहे थे।
हमने आपको EIGRP में ही एक चीज़ बताया था कि कोई भी राउटर अपने अपडेट में ये जो लिंक की इन्फॉर्मेशन होती है वो नहीं ऐड करता है, जिस लिंक से अपडेट भेजता है ना। यहाँ पे हम एक चीज़ कर सकते थे कि कुछ नेटवर्क ऐड कर सकते थे, तो रिक्वेस्ट में भी कुछ नहीं है, किसी के लिए रिक्वेस्ट नहीं जा रहा है अभी, राइट? देन अपडेट मैसेज। आप यहाँ पे एक चीज़ बस देख सकते हो कि ये जितने भी हमने मैसेजेस बात किए हैं वो सारे मैसेजेस एक्सचेंज हो रहा है। ओके, फर्स्ट हेलो मैसेज, DBD, LSR, LSU, and then LSAC. After that, routers will become neighbor. So now here, if I will verify the neighborship, so IP OSPF neighbor, so IP OSPF neighbor. So neighborship state is full. That means database is
fully synced.
yes, fully synced. So if you will check database, so IP OSPF database of router 1 and router 2, so IP OSPF database. So आप देखो दोनों का database में कोई difference नहीं है,
Link ID 1.1.
both are exactly same, right? Whatever informations are there in the database of router 1, same information we have in the database of router 2 also, right? 2 number of LSA 1 is there and 1 network LSA is there in the database of router 2 also, in the database of router 1 also. अब इसी LSA सबको थोड़ा सा डिटेल में समझना है। अब मैंने आपको क्या बताया था कि LSA क्या होता है, लिंक की इंफॉर्मेशन स्टेट। तो देखो जो राउटर 1 की LSA है 1.1.1, LSA of router 1, how many links are there?
One link is there.
One link. And in the LSA 1 of router 1 also, how many links are there? One. If you will open this in detail, like I can say router LSA 1.1.1.1, so here is the link information you can see. Link number, link header, link number 1, right? Link connected to connected network, designated router, cost on the link. This is detailed information of link. Right? Now we'll discuss what is the meaning of transit network, stub network, everything, and how you can design topology by checking the database of router. Right?
Sir, what is the LSH?
Hmm?
LSH, it is mentioning 462.
This is link
So,
state age.
For
Time.
seconds, sir.
Yes,
Sir.
in second.
So
Now,
So it is when fully handshaking timeline, yeah, when it is active. It means we configure as OSPF that time they counting the timeline
yeah,
for
when
that
router
interface.
have install it in the database, this LSA. LSA is also we will discuss. Now what we are going to discuss? Now we are going to discuss this only, this LSA only. Now we are going to discuss this LSA only in detail. Right? So first of all, see how many types of LSAs are there, and then we will discuss all types of LSAs one by one. Right? So what I am expecting now, that you are clear with types of messages and neighborship states, and which messages will exchange in which state. That's it. So is these three things clear to everyone?
सर एक बार रिवाइज करवा दीजिए मे बी बिकॉज थोड़ा सा फास्ट हो गया था.
So what I told you, we have, see here, we have 5 types of messages in OSPF: hello message, DBD, LSR, LSU, and LS ACK. DBD stands for database description, LSR stands for link state request, LSU stands for link state update, and LS ACK stands for link state acknowledgement. Right? Then neighborship state. What I told you, we have 7 states in OSPF neighborship: down, init, two-way, access start, exchange, loading, full. When we'll enable OSPF on the interface, it will start sending hello message until and unless it will not receive hello message on the interface. The state of interface will consider as down. Once router will receive hello message on the interface, initialization will start. State will move in init state. Right? And when router will see their on router ID in the receiving hello message, state will move to two-way. Right? So till two-way, only hello message is exchanged.
And router IDs are exchanged, yeah.
Only hello message is exchanged, right? Not DBD, not LSR, not LSU, not any other message. In two-way state, router is going to perform some task like DR and BDR election. Correct?
Correct.
After performing DR and BDR election, state will move to X start. In X start, routers are going to exchange empty DBD. Right? And it will negotiate the sequence number. Both routers are going to exchange the sequence number also. Like in DBD, you can see sequence number also. So IP, OSPF, sorry, in database. In database. What is the sequence number? 2. Sequence number of router 1 LSA 1. Sequence number of router 2 LSA 1 is 1. Right? So both routers.
Sir, here in an exchange state, LSA means link state advertisement.
In loading state, LSU. In X start state, routers are going to exchange empty DBD. Right? In the exchange state, routers are going to exchange the header. Header of, this is what?
Link
this
state.
Is header. This is header. See, if I am going to open this LSA, so IP OSPF database and router LSA 1.1.1.1. This is what? Header. And this is what? Detailed information of link.
Okay, sir.
Right? So in exchange state, routers are going to exchange the header, and then In loading state, routers are going to send request message. In the response of request message, router will send LSU. And after
LSU.
receiving LSU, router will send LSAC. So these three messages will exchange in loading state only. And after exchanging the database, state will move to full.
So सर ये नेटवर्क इंफॉर्मेशन कौन से वाले में LSU में करेगा एक्सचेंज?
LSU में, करेक्ट. नेटवर्क इंफॉर्मेशन OSPF में एक्सचेंज होता ही नहीं है, डेटाबेस एक्सचेंज होता है. डेटाबेस मतलब
नेटवर्क
LSA.
मतलब मैं आईपी एड्रेस की बात कर रहा हूँ बेसिकली कि
हाँ.
मेरे पास ये नेटवर्क है, मेरे पास ये है बेसिकली.
मेरे पास जितने भी राउटर 1 के पास लिंक है ना कनेक्टेड, उन सब का ये क्या बनाएगा LSA, और वो LSA शेयर करेगा राउटर 2 को. ये GRP में नेटवर्क इंफॉर्मेशन एक्सचेंज होती थी ना
जी,
यहाँ पे LSA एक्सचेंज होगा, मतलब लिंक स्टेट इंफॉर्मेशन. तभी तो हम बोलते हैं कि दोनों राउटर के पास कंप्लीट टोपोलॉजी की व्यू होगी सारे राउटर के पास, क्योंकि सारे राउटर के पास डिटेल इंफॉर्मेशन होती है, सिर्फ नेटवर्क की इंफॉर्मेशन नहीं होती है. अगर मैं यहीं पे राउटर 1 और राउटर 2 की बात करूं, बीच में EIGRP अगर चल रहा है, सो राउटर 2 ओनली नो दैट some prefixes are coming from router number 1, right? That is routing by rumors. Routers are dependent on neighbor, but here in OSPF routers are not dependent on neighbor, because routers are not going to share network information, routers are going to share link information. कि भाई मेरे पास ये लिंक है, अब तुम्हारा रिस्पॉन्सिबिलिटी है कैसे तुमको पाथ सेलेक्ट करना है, कैसे तुमको मैट्रिक कैलकुलेट करना है, सब कुछ. राइट. सो जैसे जैसे हम LSA पढ़ते जाएंगे आगे आगे, वैसे वैसे आपको चीजें अब क्लियर होती जाएगी.
So each router, it has a complete map, right, sir?
Yes, complete map. This is like GPS. OSPF is like GPS. So types of LSA. Again, type 1 LSA, type 2 LSA, type 3 LSA, type 4 LSA, type 5 LSA, type 6 LSA. You don't need to learn type 6 LSA, by the way. Okay, this is not for us. Type 7 LSA, and then type 8, type 9, type 10, type 11. Those are not in use, and even type 6 is not in our syllabus. So how many LSA we need to learn? 6 types of LSAs. LSA 1 to 5 and LSA 7. These all LSA we need to master, right? LSA 1 is called router LSA. LSA 2 is called network LSA. LSA 3 is called summary
LSA.
LSA. LSA 4 is called
ABR.
ASBR summary LSA. Type 5 LSA is called external LSA, and finally type 7 LSA is called NSSA LSA, right? But guys, I will start this LSA tomorrow. Till then you can revise the basic concepts. Okay.
सर ये मास्टर एंड स्लेव का कॉन्सेप्ट फिर या फिर MTU का?
मास्टर एंड स्लैब राउटर का इलेक्शन कहाँ पे हो, कौन स्टेट, कौन से स्टेट में?
एक स्टार्ट
Start.
क्यों होगा?
कौन अपना
बेसिकली में भी
database
कौन
maintain
पहले
करेगा?
स्टार्ट करेगा एक्सचेंज करना।
हाँ, तो आपको तो पता ही है फिर। आपके पास भी एक डेटाबेस है, मेरे पास भी डेटाबेस है। डेटाबेस मतलब LSA, लिंक स्टेट एडवर्टीजमेंट, राइट। अब हम दोनों को एक्सचेंज करना है, तो कौन पहले एक्सचेंज करना स्टार्ट करेगा? इसके लिए एक छोटी सी इलेक्शन होती है मास्टर एंड स्लैब की।
लेकिन वो किस बेसिस पे होती है सर?
हायर राउटर आईडी,
ओके।
router with higher router ID will become master router ID.
Sir, here mentioned the type of LSA. Type of LSA means link state advertisement or link state acknowledgement.
Advertisement, link state advertisement.
Sir, EIGRP में हमने
Acknowledgement is one message, type of message,
Understood, sir.
right? These are the part of database. Database means
DBD.
LSA only. Database means LSA, right? In database, what routers are going to store? These LSAs, right? And link state acknowledgement is what? That is a message, types of message. That whenever
Okay,
you will
sir.
receive the update message, you are going to acknowledge that yes, brother, I have received your update. Yes, Anjali.
Sir, in EIGRP, we were supposed to do a lab on in stuck in active state and stuck in init state. Stuck in active state EIGRP में
हाँ,
हम लैब कर रहे थे।
वो क्या था? वो तो एक प्रीफिक्स का स्टेट था ना, कि टोपोलॉजी टेबल में प्रीफिक्स की दो स्टेट हो सकती है, या तो पैसिव या एक्टिव। पैसिव मतलब टोपोलॉजी स्टेबल है, एक्टिव मींस टोपोलॉजी स्टेबल नहीं है।
हाँ, वो SIA क्वेरी मैसेज आप दिखाने वाले थे लैब में,
तो
SIA क्वेरी एंड SIA रिप्लाई।
तो वीडियो भेजा था ना उसके लिए मैं, एक छोटा सा।
हाँ, आप बोल रहे थे यहाँ भी क्लास में करेंगे।
तो नहीं किया क्या?
नहीं।
सर उसमें EIGRP में जब हम लोग एक स्टेट और देखते हैं, शो IP EIGRP इंटरफेस, तो सर वहाँ पे एक फर्स्ट कॉलम आता है 0 और 1, अगर दो इंटरफेसेस हैं तो वो क्या सीरियल नंबर
सीक्वेंस
होता
नंबर है, सीक्वेंस नंबर।
है? ओके ओके।
Sir, I have one question regarding OSPF. If we have multiple routers and they have some different areas, so that time how we configure that OSPF?
So first of all, you will understand, brother, why we come up with area concept in OSPF. Right? The benefit. Like we come up with OSPF area concept to reduce the size of database. If I will place 100 number of router in one area, then the database of all 100 routers are going to be very large. So that's why we come up with area concept. And how to configure, that is simple. We'll see the configuration of multiple area. We will have lots of lab for that. If I will show you the OSPF lab.
सर if you have one lab जिसमें हम VLAN बना के स्विच पे and then we do it, because
वो तो
वो थोड़ा
स्विचिंग में करेंगे ना VLAN।
नहीं, बट उस पे भी चलाएंगे फिर स्विचिंग में हम विद राउटर
OSPF
चलाएंगे उसमें,
हाँ।
बिकॉज सर लाइव नेटवर्क में सर स्विच की VLAN
मतलब मैं ऐसे आपको पढ़ाऊंगा कि आप कोई भी राउटिंग प्रोटोकॉल चला सकते हो वहां पे स्विच पे।
ठीक है सर।
एक बार OSPF का लैब दिखाता हूं मैं आपको, अगर खुल जाए तो।
अच्छा, EIGRP का 7 days वीडियोस इज नॉट अपलोडेड yet.
डे 7 कितनी बार तो बोल चुका हूं कि डे 7 वीडियो में प्रॉब्लम है।
ओके, एक्चुअली मैंने अभी
यूट्यूब पे है सर सिमिलर कोई वीडियो,
हाँ
पुराने कुछ क्लासेस ज्वाइन करे इसलिए।
अच्छा कोई नहीं, कोई नहीं। उसमें स्क्रीन रिकॉर्ड नहीं हुआ इसीलिए वो अपलोड नहीं है।
ओके,
बस एक डे 7 का ही है प्रॉब्लम, बाकी तो सब है ही। OSPF Here is my lab, right? You can see multiple areas are there. Area 1, 2, 10, 0, right? Other domains are also there for the redistribution. So here in this lab, we are going to cover all types of LSAs. These all types of LSAs, right? Right now in the database, we are able to see only 2 types of LSA. So IP OSPF database, only 2 types of LSAs are there, right? But when you will configure this lab, you will see these all types of LSAs in the database of routers.
सर SIA क्वेरी कब करेंगे वो वाला लैब?
अरे आप खुद से कर लो ना वो लैब, उसमें क्या है? वो जो मैंने वीडियो दिया था उसमें तो मैंने लैब ही किया है बस।
ठीक है।
जो मैंने वीडियो दिया है उसमें मैंने लैब ही तो किया है सिर्फ। वो लैब आप खुद से कर सकते
हाँ
हो।
सर वो तो हाँ ठीक है।
कौन सा वीडियो शेयर किया है एक्चुअली?
एक SI क्वेरी के लिए 5-10 मिनट का वीडियो होगा, 10-15 मिनट का वीडियो होगा एक।
ओके, तो वो YouTube पे अवेलेबल है क्या आपके चैनल पे?
हाँ YouTube पे भी अवेलेबल है और ग्रुप में भी भेजा था मैंने।
I think I am not a part of that group, so
okay, here you can search like
you
SIA
me then.
query PM networking.
Yes, okay.
ये वाला वीडियो है, 30 मिनट का वीडियो है क्या ये? इतना आपको शायद पूरा देखना नहीं रहेगा।
हाँ 30 मिनट है।
स्टार्टिंग के 10-15 मिनट में लैब हो जाएगा।
30 मिनट। Okay, it is
SIA query
related to EIGRP. SIA query.
Sir, in EIGRP IPv6 concept, there is no.
So you have to configure all the routing protocol with IPv6 also, right? Not only EIGRP. We have OSPF version 3, right? So we'll see IPv6 implementation as well. If you want to learn IPv6 implementation right now, then again you can visit to YouTube. Here IPv6 implementation is there with all the routing protocol. IPv6 PM networking. Here you can see the videos are there. I have configured all the routing protocol with IPv6. EIGRP, OSPF,
okay,
static route. Here is the EIGRP configuration with IPv6, right? Hello everyone. 18 minute. But we'll see in our classes.
Okay, sir. Did you have any previous? Okay, sir. Previous video on this named EIGRP and also wide matrix.
Yeah, named EIGRP is also there here. Named mode EIGRP PM networking. Here is the named mode EIGRP. 1 hour,
Classic
but
mode
video
and
length
okay,
is
sir.
1 hour.
Okay, sir. Okay. I will learn. And one more thing, sir. Sir, for GNS3, can I have a gigabit interface of router? Because only fast Ethernet I have.
You can add extra interfaces here. See, go to edit.
How to add a gigabit interface?
Edit, then preferences.
Okay.
Select the router, IS router, and then click on edit.
Okay, sir.
And here is the slot. Here we
Edit.
can add extra slot. You can see.
Extra slot.
In
Sir,
your
can you
case-
please add only one gigabit?
In your
Gigabit,
case, there
please
is
add.
only one FE interface, right? So here you can add like this. Okay, brother.
Sir, just only one gigabit interface. Can you please add?
Giga interface is there or not? Let- Giga is not there. Fast Ethernet link you can add, or Ethernet link you can add. Serial link even you can add.
Because in OSPF.
This is
next.
serial link. This is FE link.
Okay.
Gig link is not there. You have to use another router then.
Yeah.
Here it's there, right? You can use this router. 7200 router.
7200.
In 7200 router, gig interface is also there. You can see.
Okay, which one? Gigabit. PAG.
Yes.
Okay, sir. Sir, I don't have enterprise experience. Just for my knowledge, I am asking for the enterprise
वॉचमैन
network,
सीधे हटा रहा है भाई।
gigabit internet or 10 gigabit internet using.
वो बोल रहा है कि
Application.
बाकी कल देगा वो कोटेशन।
Yes, Karthi.
Yes, sir. For enterprise network, this OSPF and AGRP, this is all running on 10 gigabit
So
network.
concept is going to be
Just for my
same.
knowledge.
Same like on Ethernet also, on fast Ethernet or
Uh-huh.
gig Ethernet or 10 gig. It is going to be same.
Uh-huh. No, sir. How it's happening? That's I'm asking just for my knowledge only. I don't have experience on me enterprise.
What? How happening? I didn't get you.
No, what the switches they are using in capacity of this 10 gigabit link using between the OSPF and the
So
AGRP
that
in
depends
enterprise
on
network.
company to company. Some companies are using even Ethernet. Some companies are using 40 gig link also.
Uh-huh. Uh-huh.
That depends on our scenario, right?
Okay. Okay, sir. Okay.
LAN side generally we are using fast Ethernet. Fast Ethernet or Ethernet.